Everybody, I hope you did well on the quiz yesterday. I'll be grading that just as quick as I can. Today, I want you to listen to and take notes on another lesson about logarithms. We're going to be teaching you about 3 laws of logarithms. They're still somewhat important in math, but with the advent of calculators, they've lost a little bit of importance. Just like we have laws of exponents, you're going to see in the next few minutes that we also have kind of sort of equivalent laws of logarithms. So do you remember the product rule from middle school math? X to the m times x to the n equals x to the m plus n. That's the law that says x cubed times x squared equals x to the 3 plus 2 equals x to the 5th. You just kind of take it for granted. The quotient rule, x to the m divided by x to the n equals x to the m minus n. So for example, if you had x to the 6th minus x squared, that's equal to x to the 6 minus 2, that's equal to x to the 4th. It's the quotient rule. You also have the power rule that says if you have something like x squared being cubed, that's equal to x to the 2 times 3 power. So we would say that's equal to x to the 6th power. These powers help you a lot when you're dealing with polynomials and multiplication and division and stuff like that. So now, moving forward, we have equivalent, if you will, laws of logarithms. Now, for those of you who love math, I'm going to spend the next few minutes deriving these 3 laws. Those of you who don't like math as much as I do, just watch the next little bit. But for those of you who are math lovers, you might want to take notes. But everybody, at the end, there will be 3 laws of logarithms that you must know, and we'll show you how to put them to use. So, I'm going to show you how to derive, let me erase my work, I meant to do that a minute ago, 3 laws of logarithms. There's a product rule, there's a quotient rule, and a power rule, very much like there's a product rule, a quotient rule, and a power rule for exponents. Now, number 1, in order to understand what I'm doing, let's start off with a couple of assumptions. What if I said let A equal x to the nth power and B equal x to the nth power be true statements? So we're going to assume they're true. Well, if we assume they're true, well, then we must also assume that their equivalent logarithmic forms listed below them are also true. Log base x of A equals m, log base x of B equals n. Those have to be true if we're assuming the first 2 statements are true. So now watch this. I'm going to derive a product law of logarithms. If I take the above statements as true, then can I say that A times B above equals x to the m times x to the nth power, because they're what A and B are equal to? Well, then does that say the product of A times B is equal to x to the m plus n, the product rule of exponents? Now, what happens if I change this to its equivalent logarithm? Log base x of the product AB equals m plus n. But if m equals this logarithm and n equals this logarithm, then can I say that log base x of the product AB equals log base x of A plus log base x of B? So this is one of the 3 properties that you need to memorize. This is referred to as the product rule. So an example of what the product rule is saying, and I'll leave it to you to verify it, is log base x of 20, just for an example, is equal to log base x of 5 plus log base x of 4. So basically the product rule says that you can break a number up, such as 20, into a product such as 4 times 5. I certainly could have said 2 times 10. And then you can break it up as the log of one of those plus the log of the other. You may not think that's important, but it will be. Okay, deriving the quotient law for logarithms. Suppose that I start off with a divided by b. Well, wouldn't a divided by b equal x to the m divided by x to the n using the above equivalences that we assume are true? Well, then doesn't that say that a divided by b is equal to x to the m minus n by the quotient rule of exponents? So now, if I change that to log base x of a divided by b equals m minus n. But if m equals this log and n equals this log, then where do I finish up? Log base x of a divided by b is equal to log base x of a minus log base x of b. So basically what this quotient property says that you need to memorize is that if you take the log of a fraction, just for example, log base 5 of 8/9, that is absolutely equivalent to log base 5 of 8 minus log base 5 of 9. That's what we can do with the quotient rule, is we can say that the log of a fraction is equivalent to the log of the numerator minus the log of the denominator. All right, now, we also have a power law of logarithms, just like we have a power law for exponents. This one's a little bit different to derive than the first two. Suppose that I begin with, log base x of, a to the mth power. Log base x of a to the mth power. Well, can I say that that's equivalent to log base x, my apologies, of a times a times a times a until I multiply by a m times? Okay, well, according to the product rule, the log base x of a product, looking over here, right over here, is equal to the log of one of the pieces plus the log of the other piece. So can I say that this is equal to log base x of a plus another log base x of a plus ... until I have log base x of a m times? Okay, well, what's another way of saying that I have log base x of a m times? We say that I have m times log base x of a. So let me finish this one up. Here's the last law of logarithms. Log base x of a to the m has turned out to be equal to m multiplied by log base x of a. This is referred to as the power rule for logarithms. And essentially what this power rule allows you to do is that if you have a logarithmic expression with a power in it, you can essentially yank it down to the multiplication position. So an example would be something like this. If I ever saw something like log base 3 of y to the 4th, it will be to my benefit to say that that's the same as 4 times log base 3 of y. You'll see in the future that that can be helpful. Now, back when I was in high school, no snide remarks necessary, These three laws of logarithms were essential because we didn't even have scientific calculators that could handle logarithms. We had scientific calculators, but they couldn't handle logarithms. So, with the invention of scientific and graphing calculators, these three laws of logarithms have become a little bit less useful. But for those of you who in the near future, a couple of years from now, will be calculus students, these three laws of logarithms will still be quite essential to you in a couple of chapters. The chapters where you're learning how to do calculus with logarithms and exponential functions. One of the things that your calculus teacher or professor will want from you is to be able to use the three laws to expand logarithmic expressions. And basically what that means is rewrite the expression with as many logarithms as you possibly can. Okay? You'll understand when you become a calculus student that when you have a bunch of gobbledygook products and fractions and exponents within a singular logarithm, the calculator logarithms are very, very difficult to deal with, all of these products and fractions and exponents inside of a singular logarithm. So one of the things that'll make your calculus experience better is whenever you see a messy logarithm is to stretch it out into as many logarithms as you can. Now, when you're being asked to expand logarithms, what I usually tell my students is do things in this order. Look for opportunities to apply the quotient rule first, then look for opportunities to apply the product rule second, and then thirdly, look for opportunities to do the power rule thirdly. Let me show you what I mean. Look at our first example, log base 7 of 3x squared y. So notice that that's essentially 3 times x squared times y. So we have products and we have an exponent. We do not have a quotient rule. So you'll notice that the number one, the quotient rule, doesn't apply to this first example. But what I can do is I can go to the product rule and I can say that this is equivalent to log base 7 of the 3 plus log base 7 of the x squared plus log base 7 of the y. The product rule says that you can take a product and break it apart into additions of separate logarithms. Okay, now, don't you see that we have a power, that power of 2 on that x? Well, what does the power rule say that I can do with that 2? It says that I can yank it out of the exponent position and bring it to a place in front of that logarithm. So now we have log base 7 of 3 plus 2 times log base 7 of x plus log base 7 of y. And we say that this expression is fully expanded. I have written it with as many logarithms as I can. Believe it or not, it seems very contradictory. Calculus will be much easier with this expression than the original simpler looking expression. So let's go on to example number 2. Log base 8 of 3x squared divided by y. So you'll notice I can apply the quotient rule and say that this is equal to log base 8 of the numerator 3x squared minus log base 8 of the denominator. Okay, so now we got a couple of logarithms. But can't I use the product rule, secondly, on this 3 times x squared? So now we can break that apart as log base 8 of the 3 plus log base 8 of the x squared minus log base 8 of the y. And of course now we can do the power rule and yank that 2 down. So we would finally have a log base 8 of the 3 plus 2 times log base 8 of x minus log base 8 of y. And we have our fully expanded answer. And again, it'll be hard to imagine that day when you're a calculus student that this expression is easier to deal with. Okay, our third example. Log base 9 of the quantity 3 divided by x squared y. So we apply the quotient rule, and we say that that's equal to log base 9 of 3 minus log base 9 of the quantity x squared y. Now this is a very important problem to pay attention to. I'm now going to apply the product rule to the x squared times y. So this is equal to log base 9 of 3 minus, and you must do this, the quantity log base 9 of the x squared plus log base 9 of the y. You must put that in parentheses to signify that that entire product had been in the denominator. Now we can apply that power rule and say log base 9 of x minus the quantity 2 log base 9 of x plus log base 9 of y. So that has to be in parentheses because that entire quantity was in the denominator. Okay, now my last example of expanding. Notice that I have log base 5 of the square root of 3xy. Well, it's important that you remember, now that you know, that square roots are powers. Power of 1/2. So whenever you see a root, start off this way. That's log base 5 of the quantity 3xy to the 1/2, signifying that all of it had been under the square root. Now, I can separate that as log base 5 of 3 plus log base 5 of x plus log base 5 of y, and the entire quantity is to the 1/2 power. So then I can bring that 1/2 down as the power on the whole quantity that works its way down. Sorry, I ran out of room there. Okay, so future calculus students, being able to expand an expression will be essential in a couple of chapters. You do not want to do calculus on a singular log that has gobbledygook inside of it. Your teacher will tell you you need to expand it first. It'll make your life easier. Now, here's the irony, future calculus students. If after you expand a logarithm in a calculus class and you get to the end of the problem and you want to present your solution, you usually then want to recondense the expression. And so condensing expressions with the laws is rewrite the expression with a singular logarithm. Now, when you're condensing, you want to do things in the reverse order that you did when you were expanding. So you see with expanding, I said do any quotients first, products second, and powers third. So when you're condensing, you want to first do any powers, secondly, do any products, and thirdly, do any quotients. So watch this first example. You see this 2, this 3, and this 1/2. Those are powers. So I can apply the power rule and I can bring them back up into the position of a power. So then now I have log base 3 of x squared plus log base 3 of m cubed minus log base 3, I think I'll just call that the square root of n, power of 1/2. Okay, now I've done all the powers that I could. So now I say, do I see any products? Well, let me clean this up. When you finish any powers, when you see products and quotients, basically you want to do them from left to right, just like you do the order of operations. So you see here that this addition is leftmost operation. So can I use the product rule and say that those two come together as log base 3 of x squared times m cubed minus log base 3 of the square root of n. Well, now I can apply the quotient rule, and I can call this log base 3 of the quantity x squared m cubed over the square root of n, and that would be my final condensed singular logarithm answer. It's usually what you do when you're finished with a logarithm problem, is you recondense. Okay, my last example. You'll notice that this time the subtraction is followed by a quantity in parentheses. Well, just like the order of operations has been telling you for years to do parentheses first. Whenever you're condensing logarithms, follow that rule. So 5 log base 7 of a minus, well, the first thing that I can do within this quantity is bring the 3 and the 2 up as powers. So that would be the quantity log base 7 of x cubed plus log base 7 of y squared. Okay, well, I'm still in the parentheses. I can now apply the product rule. So I have 5 log base 7 of a minus log base 7 of x cubed times y squared. Okay, the next thing I can do, I could have done this a while ago, is bring the 5 up. Log base 7 of a to the 5th minus log base 7 of x cubed y squared. Well, the product rule would say that I'm finished with a singular logarithm base 7 with an a to the 5th numerator over a x cubed y squared denominator. So that is your 3 laws of logarithms and how to use them to expand and condense expressions. You've hopefully taken notes. Now you'll see that there's an attached practice sheet as well.